Okay, so what I was saying is that when Copernicus proposed and Kepler defended the sun-centered model, which Kepler defended this a couple decades later, a few decades later, it was resisted by the public on the grounds of common sense. The question was, if the Earth is orbiting around the sun and we're on the Earth, why can't we feel this motion? Why can't we feel the Earth going around the sun? Okay, and I want to stress that this may seem like a silly question, maybe, to some of you now. This is actually a very good question. Okay, so let's think about this just a little bit. Okay, before we move on, let's think about this question. Why can't we feel the Earth's motion around the sun? Okay, so let's start off by thinking about the sun and the Earth going around it. Okay, there's the sun. There's the Earth. This circle I've drawn is meant to be the orbit of the Earth around the sun. Of course, it's not exact, but it's good for what we're trying to do right now. And I'm drawing the average radius of the Earth's orbit, r bar, and the average velocity, average orbital velocity, v bar. Okay. So we now know that the average orbital velocity is about 30 kilometers per second, the average velocity of the Earth orbiting the sun, and the average orbital radius is about 150 times 10 to the 6, 150 million kilometers. Okay. Now, so let's calculate the Earth's acceleration. Okay, so as it goes around the sun, of course, it's going around in roughly a circle. That means that it's undergoing acceleration. Even if it's not changing speed, it's changing direction, so the velocity is changing. And we know, right, this is going to be centripetal acceleration. And you should remember from your mechanics class that the centripetal acceleration is equal to the velocity squared divided by the radius. Okay, so if we plug in numbers, we get 30 kilometers per second squared divided by 150 times 10 to the 6th kilometers. Now this is equal to 6, if you work it out, it's equal to 6 times 10 to the minus 3 meters per second squared. Okay, so that's the centripetal acceleration of the Earth as it orbits the sun. Okay, let's compare that. Okay, let's compare this with gravity. Okay, so the ratio A over G is equal to 6 times 10 to the minus 3 divided by roughly 10. Remember, gravity is 9.8 meters per second squared. Okay, and this is equal to 6 times 10 to the minus 4. So compared to gravity, the centripetal acceleration of the Earth going around the sun is very small. It's less than a part in 1,000. So it's less than a thousandth as important as gravity. Okay, so it's pretty small, which is basically why we don't feel it. Now I'm here neglecting other effects such as the Earth's spin, okay, the Earth's rotation, right? That plays a role, which is still small compared to gravity, and the motion of the sun in the galaxy, and the galaxy spinning and all that. So I'm basically neglecting all that, and what this means is, as we'll see, is that the surface of the Earth is basically an inertial coordinate system. Is approximately inertial.